So today we're going to learn about quadratic functions. This problem says Coach Nelson decides he is going to throw a parachute man off the roof of the school. All right, here's our parachute man, and let's quickly just sketch what's happening. So here's the school. Here's the ground. Some windows. Here's our school door. And here is Coach Nelson. And he's holding a parachute man. And he's going to throw him off the school and onto the ground. All right, so it says that the school roof is 12 feet off the ground. So that means that this height here, he's 12 feet from the ground. That's 12. All right, it says the parachute man is initially thrown up at a velocity of 4 feet per second. So he's thrown up at first, okay? So he's not thrown straight down to the ground. So he's going to go a little bit higher than he started out. How long will it take the parachute man to reach the ground is the question. How long will it take to reach the ground? All right, so it says assume the function below models the height of the parachute man y, so y is the height, in a relation to the amount of time that has passed x. So x is time. So you see that our graph here has labeled those things accordingly. X is time. Whoops. Let's get a highlighter back on. X is time and y is height. Now what we're going to need to do to graph this, because it's going to show us how high the parachute man is over the course of time, we need to make a table and plug values in for x. So I'm going to make a table here, and I'm going to make a pretty big table because we want to have lots of space to plug in any x values we want. So the first x value, because remember x is time and y is height. So the first x value that we would want to try is the first amount of time would be 0. We're talking about seconds here for time, so 0 seconds. So at 0 seconds, Coach Nelson has almost thrown the parachute man, but not yet. He hasn't actually thrown him yet. So at 0 seconds, I bet you that the parachute man is still at the top of the building. So he should be at a height of 12 feet off the ground because we hadn't been thrown yet. But to find out, to be sure, we're going to plug 0 in for x. So we're going to take our equation and plug 0 in. Whoops, let's make that a little cleaner. We plug 0 in for both x's, for that x and that x, because there are two of them. We have to put the 0 in for both. Let's clean this up a little bit too. Sorry, that's pretty ugly. All right, that should be, there you go. That's a little better. So now we just have to do the math and figure out what we get, and whatever we get will be the value of y over here. So 0 squared is 0 times 0. That's the first thing we're going to do. And 0 squared is 0. So that just becomes 0. We can multiply it by -1 here in a second. Okay, 4 times 0, because that is parentheses, so we need to distribute that 4. 4 times 0 is 0. So plus 0 plus 12. Now we can do the distribution on this first parentheses. -1 times 0 is also 0, because anything times 0 is 0. So now we have 0 plus 0 plus 12. Well, 0 plus 0 plus 12 is just 12. So y will be 12 when x is 0, like we predicted. So on our graph, we can put our first point at 0, 12. Right there. 0, 12. All right, now I'm going to erase the work so we can try the next point. The next point we want to try is, well, what about after, let's say, 1 second? So after 1x, what will happen? We're going to erase the work. Now we can leave everything besides these zeros because we're just going to replace those, because the new x we want to try is 1. We're going to replace those with a 1. All right, so let's do the 1 squared now. 1 squared is 1 times 1, which is 1. 4 times 1, because we distribute the 4, is 4, plus 12. All right, now we can distribute the -1. -1 times 1 is -1 plus 4 plus 12. So we can do the math. -1 plus 4 is 3 plus 12. 3 plus 12 is 15. So after 1 second, it will be 15 feet, the parachute man. So that we can plot on our graph. 1 second, he goes up. And that's because at the beginning of the problem, it told us that Coach Nelson is going to throw him up before he starts to fall back down. All right. So now let's keep going. Let's plug in the next values and start to see what this graph looks like. All right. Let me fix that. There's the parentheses. Okay. Now, oops, I forgot the other one. Now the next value we're going to plug in is what happens at 2 seconds. So we plug 2's in for both x's. Well, 2 squared is 4 times -1. 4 times 2 is 8 plus 12. Now we can distribute the -1. We're just evaluating over and over. -1 times 4 is -4 plus 8 plus 12. -4 plus 8 is 4 plus 12 is 16. Okay, whoops. Let's fix that. 6. There you go. Okay, so at 2 seconds, the parachute man has kept going up. He's now at 16 feet. All right, we keep going until we find out when he hits the ground. And guys, you can also use your calculators on your phones to do this. You just need to do it one step at a time if you don't have a graphing calculator. So you just do like the square first, then you can like multiply each step while at the same time writing stuff down like I am. That's a good way to do it with your phone calculator. So now let's try 3 seconds. At 3 seconds, what happens? That's a 3. Well, 3 squared is 9 times -1. 4 times 3 is 12 plus 12. 9 times -1 is -9. 12 plus 12, I'm going to do that part first because we can, is 24. All right, and then -9 and 24. Well, let's see, that's 9 less than 24. All right, so that would be 15. So at 3 seconds, we're back to 15. So he started to come back down, the parachute man. He went all the way up to 16 feet, and now he's starting to float down. All right, let's erase. Now I'm going to save us a little bit of time. I'm just going to skip ahead a couple numbers. If you keep plugging in 3 and then 4 and then 5, I'm actually just going to give you some of the answers until we get to the actual final answer. But you can do this on your own if you choose to. So if we go to 4 seconds and we plug 4 in, we're going to get 12 out. He's starting to fall a little bit faster. 4 and 12. If you go to 5 seconds, he's going to be at 7. At 5, we're going to go to 7. And then when we get to 6 seconds, it will be at 0. So I'll plug that one in to show you guys. All right, because that is where he hits the ground at 6 seconds. It's going to be at 0. So if we plug 6 in to both of these x's, 6 squared is 36. 4 times 6 is 24 plus 12. Now, -1 times 36 is -36. And 24 plus 12 is 36. And if we add -36 and +36, we get 0. So that's where my 0 comes from right there. All right, so we've now graphed our parachute man. He's being thrown off the roof. He goes all the way up to 16 feet, and then he comes falling down, and it takes him 6 seconds to hit the ground. So what we've actually graphed here is called a quadratic function. A quadratic function, to make it really simple, is any function that has x to the power of 2. If you see x to the power of 2, you have a quadratic. So all these problems we've been doing with factoring, they've all been quadratic expressions. That's because they don't have the y equals. And so now we're taking those quadratic expressions and we are including this y equals here, right there. And now it's a quadratic function. And this is the third and final type of function we're going to study in Algebra 1. And you can see the graph it makes is kind of this funny U-shaped graph. We're now going to take a look at that on Desmos. We're going to graph the same equation on Desmos. All right, so now we're going to graph the exact same function on Desmos. You can see on the left here, I've made the same exact table, and we are ready for these points to show up on our graph. We've labeled the axes. The y-axis is height, the x-axis is time. We're ready to go ahead and have those points appear. There they are, the exact same graph. Now, what I want you guys to understand is that these are only the points that we put into the table, but we could have put other points into the table too. In fact, if we had put all the points imaginable, we would have gotten this graph, this whole graph. Now, let's talk about what parts of this graph actually make sense for this problem. For this problem, the time 0 is the very first amount of time that we might want. And the last amount of time that we might want is 6 seconds, because we don't need 7 seconds. After 6 seconds, the parachute has already hit the ground, and the additional time doesn't make any sense. Before 0 seconds, -1 second, -2 seconds, all this on the left side here doesn't make any sense either for this problem, because Coach Nelson has not yet gotten onto the building to throw the parachute man. So we don't really care about that stuff. That's before 0 or after 6. So we can go ahead and graph just the part of the function that we want from 0 to 6. What about the line? Should it be connected or should it just be dots? I would argue that it should be connected, because you can have points in between. You can have points, you know, in between our points at, like, let's say 0.5 seconds and a height of 13.75 feet. That makes sense. The parachute doesn't jump all the way from 12 feet to, 15 feet. It slowly increases as it's being thrown. So we want to connect our points. It's a continuous function. I will show you, though, that every single point that we have on the right side of the graph also appears on the left side of the graph to make this perfect U shape. Now, you can see that there are points here and here that are symmetrical, and here that are also symmetrical here. And there would be one here. We can actually figure out what that one is if we want to add it in. So there's symmetrical points on both sides. And that is true for every single quadratic function. Now remember, a quadratic function is just a function that has x squared in it. So this is a quadratic function, and it has a name, this type of graph. This type of graph, it's called, I'm going to label this for you. This is a quadratic function, and this type of graph, the shape of the graph is called a parabola. All right, so that U shape that you see is called a parabola. All right, so all quadratic functions make this U shape and have the symmetry that you see, where the points on the right side also have points on the left side. Now, we're going to talk about some specific vocabulary that you need to know about quadratic functions. The first vocab word that we're going to go over is one you guys already know, and that's y-intercept. So the y-intercept for a line is just where the line crosses the y-axis. For a quadratic function, it's the same. The y-intercept is right here. Okay, it's this point right here. It's where the quadratic function crosses the y-axis. That's the first vocab word, and it's not really new. The next vocab word you need to know is that every quadratic function has a top or bottom point, a highest or lowest point. And it's the only point on the quadratic function that does not have a symmetrical point on the other side. So that's obviously, I'm talking about this top point here. That point's name, it's called our vertex. So this point up here, 216, is called the vertex. And you see it says maximum next to vertex. So every vertex is either a maximum or a minimum. If the point is on the very top of the graph, it is called a maximum. Some quadratic functions are flipped over and open up rather than opening down like this one. And we'll get to some examples like that later, but if you see one that's open up, the vertex is called a minimum. But for this graph, it's a maximum since it's at the very top. Now, the next point that you need to know about, the next vocab word, so that is a new vocab word, vertex. So make sure you write that word down. The next vocab word you need to know about is something, again, that we've already talked about. These points on the bottoms are called the x-intercept. So that is an x-intercept, 6, 0. And it's a very important point for this graph because that's the point where the parachute man hits the ground. After 6 seconds, he's at a height of 0 feet. He's on the ground. And that was the original question. How long would it take? 6 seconds. So because these points are so important, we give them special names. X-intercept makes sense. It's where the line crosses the x-axis at 6. But we also call them these things, aka root, solution, and 0 are 3 other names for x-intercept that you will see and that you need to know for Algebra 2 when you get to that course. So make sure x-intercept is the same thing as a root, a solution, or a 0. It's where the graph crosses the x-axis. There is another x-intercept on the other side. It's right here at -2, 0. For this problem, that point is not really part of our function, but it's important to know that quadratic functions usually have 2 x-intercepts, or you could call them roots, solutions, or 0s. Most of them have 2. There are some situations where it will only have 1 x-intercept, and there are even situations where a quadratic function has no x-intercepts. Maybe you can imagine what that looked like. We'll get to some problems like that a little bit later. All right, so the next thing that you need to know is that every quadratic function, every parabola, because remember this graph is called a parabola, that's just the name of this shape. Every parabola is symmetrical. And so we could draw an imaginary line down the middle of it, cutting through the vertex, that would split the 2 sides perfectly. And that imaginary line, we're going to actually draw it. So here it is. That imaginary line is called the axis of symmetry, and it has an equation associated with it. The axis of symmetry for this graph is at x equals 2, because that is the x value that it has, that it crosses on the x-axis. It will always also be the same x value as the vertex's x value. So that 2 from the vertex is the same as the x equals 2. So this equation for this axis of symmetry is x equals 2. Now, the only other things we need to talk about is we just want to summarize everything new that we learned. So we already knew y-intercept, we already knew x-intercept. So the things that we learned that were new, we learned that the vertex of this graph is the top point. It's at 2,16, and it's a maximum. We learned that this graph has x-intercepts. It has 2 of them. They are also called roots, solutions, or 0s. They are 6, 0, and -2, 0 here and here. And we learned that the axis of symmetry, which I'm going to just abbreviate AOS, axis of symmetry, is the line that cuts the graph in half, and it is at the equation x equals 2. We could write for that line. So those are all the vocabulary words that we're going to learn this week about quadratic functions. Make sure that you study this, and if you get stuck, I will also post this picture for you guys to kind of review as you do some of the practice problems.